We will study the SN1, SN2 and SNi mechanisms of the nucleophilic substitution reactions. And for this, first of all, let us study about the SN1 mechanism, which is nucleophilic substitution following first order. In SN1 mechanism, we take one example of tertiary bromide, tertiary butyl bromide, on which there is nucleophilic attack of hydroxyl ion, and as a result, alcohol is formed. This is There is substitution of bromine by the OH minus group here, and this is the attacking region which is negatively charged. So it is called the nucleophile. There is nucleophilic attack on the alkyl halide, and there is formation of a substituted product. This is tertiary butyl bromide. It is found that the rate of this reaction is equal to one constant into the concentration of alkyl halide, and it is not dependent on the concentration of hydroxyl ion. Here we can see that there are two reactants present, which is one of the substrate and the other is the attacking region, but the rate is dependent on only one of these, means alkyl halide only. Why it happens so? That is uh, explained on the basis of the SN1 mechanism, according to which the substitution which is taking place is a two-step process. This is a two-step process. In the first step, what happens that tertiary alkyl halide produces the carbonium ion. Carbonium ion is having positive charge on the carbon, and bromine goes out like Br minus. This is the slow step. And the second step, which is the attack of nucleophile on this tertiary carbonium ion, which is formed in the first step. Now here nucleophile is attacking, and what is formed? Alcohol. This is the fast step. So obviously the reaction rate of the reaction is dependent on the slow step, and slow step involves only the concentration of the substrate, which is alkyl halide and not OH minus. So the rate is dependent on the concentration of alkyl halide only. And in this reaction, there is racemization. mesmerization and inversion, both taking place because both the back side and the front side of the carbocation are available for the attack. Now we will see what happens in case of the SN2 reaction mechanism. In this mechanism, we are taking the example of methyl bromide, on which the attack of nucleophilic agent, that is nucleophile OH minus, is taking place, and methanol is formed with bromine getting removed from here. So there is substitution of bromine by OH minus, and now the rate of the reaction is equal to one constant into concentration of alkyl halide into the concentration of hydroxyl, that is the nucleophile. Here the nucleophile concentration is also present in the rate expression. It means that it is also affecting the rate of the reaction. The reason is that it is a single step process. SN2 is a single step process. Only one step is there in which the nucleophile attacks on the substrate, that is alkyl halide, and there is breaking of the CBr bond and the formation of COH bond, both taking place at the same time, and partial negative charge is getting developed on the bromine and hydroxyl ion, and partial positive charge on the carbon, and ultimately it forms the alcohol. And here there is inversion of configuration taking place. Why? Because the front side here, the front side is blocked. So this hydroxyl ion can come from the back side only. So both the sides are not open for the attack by the nucleophile. So there is inversion of configuration. Inversion of configuration taking place. Attack of nucleophile is on the back side. Now SNi mechanism. In this mechanism, uh, there is retention of configuration. This is the feature of the SNi mechanism, that there is retention of configuration even when there is no possibility of a neighboring group effect. Means that the groups present on the carbon are not favoring any such retention of configuration. Still, there is retention of configuration. So, why it happens like that? Let us see. Actually, SNi means substitution nucleophilic internal. And this is specific regioselective and not often encountered reaction mechanism. Means it is not often encountered and it is a rare mechanism. Still it's taking place and it is a somewhat different from the SN1. There is internal substitution, that is nucleophilic. Examples of this type of mechanism are chlorination of alcohols with thionyl chloride. For example, chlorination of alcohols with thionyl chloride. Thionyl chloride. Decomposition of decomposition of alkyl chloroformates. Formates. The main feature being retention of configuration. Now, some reaction which shows how SNI mechanism is taking place. Let us take example of one alcohol which has carbon has two alkyl groups attached to it, R and R dash, and it is reacting with thionyl chloride SOCl2. So there is removal of HCl from here, and what is formed here? C R H R dash O S O Cl plus HCl. Now this will give the formation of carbonium ion, carbocation here, and one negatively charged species, that is now this is just like the SN1 reaction, first step of the SN1 mechanism in which carbonium ion was formed and the other negative group was also produced from the same molecule. Similar, it is just like the SN1 step, first step of the SN1 reaction. Then there is internal arrangement like this, that the one part of the leaving group, this is the leaving group, and one part of this means the electrons present in SCl bond, they come here, reach the electron deficient site here, which is C plus, and then what is formed? Chlorine gets attached to C plus, and CCl bond is formed, CCl bond, and SO2 is produced. So, in SNI mechanism, one part of the leaving group must be able to attack the substrate. Means this part of the leaving group, which is Cl, it should be able to attack the substrate. And then during its detachment from the rest of the leaving group in the process, while it's getting detached, it will be able to attack the electron deficient site here. The first step in SNi is same as the very first step of the SN1 mechanism. This one. This is just like the first step of the SN1 reaction mechanism. That is the dissociation into the ion pair. You can see here, first step, the SN1 mechanism. There was formation of an ion pair, and here in case of the SNi mechanism, there is formation of an ion pair here. But this is the SNi mechanism where there is substitution nucleophilic internal. Now, part of the leaving group attacks necessarily from the front side. It is attacking from the front side because it is unable to get to the rear, resulting in the retention of configuration. That is why the configuration is retained. So, SNI mechanism is relatively rare, and one there is another example of the SNI mechanism, which is the decomposition of alkyl fluoroformates. Alkyl fluoroformates ROCOCl. It gives RCl plus CO2. And now this mechanism is like this. ROCOCl gives positively charged species and negatively charged means formation of an ion pair. Then carbonium ion here. Now this is the leaving group, negatively charged group, and part of it means chlorine. Here, this electron it will attack at the substrate, and then RCl will be formed and CO2 will be produced. Now, this is the another example of the SNI mechanism. I think it will be clear now what is the difference between the SN1, SN2 and SNI mechanism. Thank you.